Yeah, we are talking about the CIA mechanism. First, as I told you, that confidentiality to keep the data and resources hidden from unauthorized user. And integrity, we talk about data and origin integrity. Third one is related to the availability. Availability says that if you are an authorized user, you can access to your data and resources as and when required. There is no point to stop you to get your data and resources. That says that enabling access to data and resources. But if a user is an unauthorized user or an intruder or a hacker, the data is not going to available to that particular user, right? So security always focus on three things. One is confidentiality, integrity, availability. And you have to ensure that when sender is going to communicate with the receiver, there should not be any third party or hacker or intruder can manipulate the message sent by the sender. So in order to manipulate the sender, the data or anything the sender wants to communicate, so hacker anyhow gets some kind of credentials or guess the credentials, or you can say get the credential in any way from the sender. So you have to keep your credential in a safe place, or you should not reveal your credentials in order to avoid any kind of attack. So here you can see there are a lot of issues and challenges are there. Like securities is having challenges, privacy is also having challenges, trust and reputation is also having challenges. So overall, we can say these are the nothing but the risk associated with the cloud security. So if you are executing any action that compromise the security of information, then it leads to an attack. So in day-to-day life, also in news and social media, also we came to know different kind of attacks. We are also getting the phone calls from uh, different unknown numbers, and they are asking us our credentials, like you can say our debit card number, credit card number, PIN, other things to play some kind of attacks. So if you see these attacks, basically these attacks, if you look into the attacks can be considered as four types. The first attack type you can say that is called as interruption. Okay, this is one type of categorization. First one is called as interruption. What is actually interruption? Sender, we want in between sender and receiver or destination, or source or a destination, or sender or receiver, whatever maybe you consider. The message should be encrypted by the sender, and it should be decrypted by the receiver or destination. And there should not be any kind of interventions or interruption in between the sender and the receiver or source or destination. So what actually interruption says? Interruption means like sender is sending some message or source is sending some message. In between, anyhow, the message is stopped to deliver it to the receiver. Receiver is unable or destination is unable to receive the message from the sender. Either some kind of attack is launched, or the message is corrupted, or the media is having some problem. It may be anything. So it is an interruption when a source is communicating a message to the destinations. So that is nothing but attack on availability. Like sender has sent something, but destination or receiver has not received it. Right? Sender claims that he or she has sent a message, but the receiver claims that the message was not delivered to him or her. That is called as interruption. There is another kind of attack that is called as interception. Interception. So what happened here? It is attacking on confidentiality. I told you CIA, right? CIA is confidentiality, integrity, and authenticity, availability. So here, if I name it by 1, 2, 3, so if there is an interruption happen, so the type of attack happen is number three, that is attack on availability. Interception says that sender or source communicate a message to the uh, destination, right? But in between, okay, in between the transmission, there is a interception. Either the hacker wants to know what kind of message the sender communicates with the receiver or destination, or the intruder wants some kind of modification in the text. Right, this information, this message is reached to I. I has modified it and sent that message to the destination. Okay, so here you can see send the message is delivered to that destination, but somebody can get the information or somebody has manipulated that information. So if you do this one, the type of attack happen here, that is called as confidentiality. That is, if there is an interception, it leads to attack on confidentiality. Now, there is another type of interceptions you can say, that is called as a modification. Okay, interception you can say someone wants to modify, or someone is just observing the scenario without modification. So explicitly we have modification, like sender wants to communicate, it reaches to some intruder or a third party has manipulated, then it is received by the destination. So integrity of the question of the message is now question mark. Whatever message you have sent, that is modified, right? Integrity is nothing but some constant is there that you have violated. Okay, so it is leading to the attack on integrity. The second, okay, and the last one is called as fabrication. Like I told you, interception, right? Interception case, somebody is observing, right? Observing you. At what point of time you are sending message, what kind of message you are communicating, who is the intended receiver of your message. He's observing, he's not actually attacking something, okay, or he is not manipulating anything. So once he observes something, right, in between the source and destination, source has not initiated any message, but this third party has initiated one message and delivered to the destination. And this intruder pretends that it is sent by the sender. Okay, it is not originally started from the by sender S, but I is initiated a you can say message. Okay, fabricated message and sent to the destination. And once the destination receives this message, destination feels that yes, this is originated from the sender. Like day by day we are getting different emails, right? Sometimes the email is looking just like an original email. Okay, that looks like an original email, but it is belongs to a fake email. Like some company name is there, let's say ABC, somebody will write ALOC. Okay, so whenever we look into it, looks like it is ABC. Such type of attacks also can happen uh, in a normal medium, or you can say in cloud also. So if you go for threat, so if you go for different classes of threat, also you have a lot of type of threat. Like if you disclose any information, that also leads to threat. If you have deception, that is modification, or if you are doing spoofing, repudiation of original. Sometimes the receiver claims that I have not received message. Sometimes sender claiming that I have sent the message. Right, there is a conflict between the sender and receiver. Right, denial of receipt is also comes under the deception. We have another threat type that is called as disruption. Okay, disruption is nothing but our modification is an example. Another is called as usurpation, that is modification, spoofing, delay, and denial of service. These all are belongs to different kinds of threat. Now let us focus on some of the issues and the challenges. You know, if you look into customer perspective, user perspective, so the cloud infrastructure is look like a virtual infrastructure, right? But if you look into cloud service provider perspective, CSP perspective, this infrastructure is a real infrastructure. So there is two viewpoint. One viewpoint with respect to the user, another viewpoint with respect to the cloud. If you look into customer perspective, customer is not owning infrastructure, right? Customer is not purchasing infrastructure. A user is not, or customer is not maintaining that infrastructure. So the entire infrastructure is a virtual infrastructure for a user. But when you see cloud perspective or CSP, cloud service provider perspective, CSP has to manage the infrastructure. CSP has the administrative control. CSP has to do the maintenance, deployment. Everything is done by cloud service provider. So in that side, it is a real infrastructure. Now, there are some important issues that how to integrate this real infrastructure with virtual infrastructure. Or you can say mapping between the real infrastructure and virtual infrastructure. It really a challenge to map the real and virtual infrastructure to integrate the real and virtual infrastructure. So we have different security issues. We have different legislations also. Like in each and every country, they are having different laws and regulations. Right? The laws and regulation of one country is different from another country. Now we want laws and regulation with respect to data and resource. Right? We are in cloud. We are talking about the data and resource. So we should know what are the security policies or laws, regulations, legislations applicable on the data, so that integration of real and virtual infrastructure can be possible. And also, if you are keeping your data outside your organization boundary or outside your country boundary, what rules and regulations is enforced to that particular data? So obviously, the traditional way, if you look into the solution is our cryptography mechanism. So cryptography says that you can encrypt the message, you can decrypt the message. Either you can use a single key in the case of symmetric key cryptography, just like two persons are sharing a same room and there is a lock with two keys. One key is with one of the roommate, another with another roommate, right? So whenever they want, they can unlock the room as per their convenience. Right? If somebody is locking and another person can unlock because that person is having key. So this such type of cryptography is called as our symmetric cryptography, right? But if you go for asymmetric cryptography, here we have an advanced concept where we are not sharing the same key. Rather than we have a public key and we have a private key. Right? We have a public key, we have a private key. For example, if you consider our email system, in email case, we have username and we have password. If you look into username is public, right? Username is public, but password is private. So if somebody wants to send a message to you, that person should know your public key, means email ID. But somebody wants to read the email received by sent to that person or received by received from received to his email box, then he or she needs a private key. So such mechanisms are called as asymmetric cryptography. So when the data is making transition between the source to destinations, we apply the process of encryption and decryption. This side we have encryption, this side we have decryption to protect the data. So that any intermediate or any person who wants to get this data the data is in encrypted form. Okay, if he can encrypted form, so if he can decrypt it, then only he'll come to know the message. But if it is in the if he knows the key, then only he can encrypt. Otherwise, it's just like a binary file, right? Or some files with some special character and other things. So it is unable to understand what actually they are communicating. Okay. So when you transit the data from private premises to the cloud infrastructure, users data is available in its own infrastructure, which we call as your private infrastructure. So when a user or its organization wants to move the data from their premises to the cloud premises or cloud infrastructure, so there is a movement of data from their infrastructure to cloud infrastructure. So in between, you have to ensure that the data is safely transferred from their own infrastructure, customer infrastructure, you can say, to the cloud infrastructure. But the problem is that when you process something, okay, if the data can be transferred through encryption and decryption mechanism, okay, or symmetric, asymmetric, whatever security mechanism you have studied, okay, you can do it. But when you want to decrypt, okay, when you want to process something, when you want to get some information, right? Encrypted form, you cannot consolidate something, right? Or you cannot extract some information. So while you are processing, this data or information need to be decrypted in the memory or storage, you can say. Okay. Storage case, if the data is you want to keep as it is, then it is you can be transferred to the cloud infrastructure and you can save it. But if you want to process something, you need to decrypt it. Like our RAM, right? We are talking about virtual CPUs. So vCPUs case, what we are doing? If you know the number of virtual CPUs, then you can process something, right? Suppose you have taken an instance and you want to execute something. So in that case, you need to decrypt into the memory. So the main weak point here, while we are processing the data in the cloud. So here, if the intruder or attacker can launch some kind of attack, then it may create a problem, or it may be one of the security loopholes in the system, right? So virtualization allow us capturing transparently the memory pages of an instance. That's why the data can be obtained by malicious provider. So the provider, the data can be also reached to a malicious provider. Some provider can give you attractive offer and you can get your. It is also can possible, right? Okay. An attacker can launch some kind of attack. Okay, if there is a malicious provider, sometimes attractive offers are given to us, so we are looking into that offer and we migrate our things to that cloud service provider, but that cloud service provider is not a genuine provider. So either intruder can do also, and if we question on the integrity of a provider, cloud service provider, that also having issues related to the security and privacy issues on our data as well as the resources. Now, in one example, give you the clear picture. Like if you look into United States legislation, okay, if you go for United States legislation, US legislation has given extreme power to their government agencies, or you can say US military, to acquire the confidential data if if they suspect that a data leads to the nation security issues. Suppose somebody is sending one email, right? Let's say the government agencies or the military agencies, they found that they feel that this data may lead to some may contain some suspicious information which may question or which may cause the problem related to the nation security, okay, or their country security. So without any intervention, they can get the data, right? Without require any special permission, they can track the data and they can get the details of that particular data. But the problem happens when US organization or the people of US, they are using cloud. So when they are using cloud, their data is not limited to their boundary. Like if I take US East in Amazon EC2, right? US East or US West or Europe or any other region is I'm using. It is out of the boundary of our country, right? Or they are using our Mumbai. They are hosting something in our Mumbai server, right? So that is inside the boundary of our country. So when the organization starts using cloud services, their data is stored in other places. Like let's say US data is stored in Europe. So US government agencies or military has no control over it. Okay, they cannot get this confidential data if the data is stored in the cloud. So this is also one of the important issues in the cloud security, right? So there is no point to get this data, right? You cannot get the data if the data is in outside the boundary or outside any country, your country or continent, then it is difficult to get. That is a major issue in the cloud. There is another example you can see here, like if you talk about European common market. So European common market has established its own legislation. So in their legislation, they mentioned that if the data at rest, like if you are keeping your data in your hard disk or SSD or any pen drive or any storage, so the data is at a rest state. Okay. But if you want to send the data to your friends or to me or someone, then you are making transition in the data. So whatever rules are there that is applied to data at rest, if you keep the data without any movement, that rule is different from the rules that apply when the data is in transit. So when you make a transition, when you make a transition, the rules enforced to the data is different. When the data is at rest, the rules you applied, that is also different. So rules varies with respect to the condition of the data. So although they have their own legislation, they have two different rules. So it may cause problem. Like in COVID situation time, if you take a practical example, each and every state or a district is having different rules and regulations. If a state or if a district is having major cases or declared as a containment zone, their policy is different. So when you go for cloud computing and you deploy across the different states and countries, you will face a problem that is called as multiple jurisdiction problem. Okay, there are multiple rules and regulations are there, multiple laws and regulations are there, or you can say legislation is there. So you will face this problem across various country, if not country name, or you can say in the downside, you can look into different states or different uh, you can say districts, right? So that is one of the issues. Some other issues apart from the this legislation is that customizations. We cannot make all the cloud service provider are not providing customization. Like one of the popular cloud service provider, Google. Google is not providing customization to their customer. They have developed some applications, and if you are going to continue or going to use the resource of the Google or want to opt for some kind of applications, then you have to be use their own applications. You cannot modify these applications. So whatever security policies are there, that security policies you have to only choose. You cannot enforce your own security policy. So that is also one of the issues and challenges. And obviously the problem in the cloud, also one of the issues that is not related to security. If the one connectivity or internet is not there, then we can suffer the problem of not getting the services on the cloud. So cloud computing suffers from the inherent latency. That is one of the issues. Now, if you look into The architectural design. We have discussed about cloud computing architecture, right? Different cloud computing architecture we have discussed, right? We have discussed about market-oriented architecture. We have discussed business perspective, what is the architecture. So if you see such architecture design, it also face some kind of security issues, or you can say open challenges. One by one, we are going to discuss. First one is called as service availability and data lock-in problem. So already I told you security has three components. One is CIA. One of the major one is availability. So that is a generalized view, right? Now you look into cloud view. Service availability. We need the service need to be available 24 into 7 without any downtime. Even if there is a downtime is there, that should be as minimum as possible. So, but people launches some kind of attack that we have seen availability in order to not get 100% availability. People, what you can do, they can apply modification type of attack. Okay, they can go for interception, something like that, right? So, first one is called as a distributed denial of service attack. Denial of service means you are denied to get a particular service. Right? You are typing www.xyz.com and you are not getting service. So that is considered as a denial of service. If it is done by an attacker or an intruder, we can call that as a denial of service attack. Not only because of attack only you are not getting the services. Sometimes the server is down. Sometimes some other issues are also there for which you are not getting service. But if this leads to an attack, if an attacker has launched something, because of that you are not getting the service, we call that as a denial of service attack. So there is another famous attack after DOS attack. DOS attack is also very popular attack. So people try to use denial of service attack from various parts. So by applying DOS attack, you can make the service unreachable in a particular region, right? In a particular country or particular state. But if you launch such attacks in various places of the world, various part of the world, so that the service is not going to be available all over the world or most of the part of the world, then we call that as a distributed denial service attack. Okay, so we are not launching the attack from one point. We are launching the attack from various parts. That's why we call that is a distributed denial service. Okay, attack. Similarly, we already discussed about data lock-in problem. Data lock-in problem means if a customer X, okay, uses the service of a cloud service provider Y, customer X using the services of cloud service provider Y. Like we all are using Gmail, right? Our emails are stored in the Google server. Tomorrow, let's say another provider is there, let's say CSPJ, and we decided that we have to migrate from Y to Z. So our emails are stored with this cloud service provider. Okay. So if you want to migrate to another cloud service provider, your data is stored here. The data migration is not possible if the common APIs or libraries are not used by both cloud service providers. So customers are dependent on a single cloud provider. We cannot easily move to other provider due to dependencies, due to type of applications. So it is not possible. Like we are using Gmail. Tomorrow I'll tell you there is another mail, let's say Xmail. You move to Xmail. So many people will hesitate to move to Xmail, right? Because our data, everything is associated in the Gmail, right? Even if Gmail is charging some amount in future after 10 years or 20 years, we will definitely purchase that one rather than moving from one email to another email, right? Until unless we will get some easy migration process, we are not going to use that one, right? Similarly, there is another issue that is called as data privacy and security concerns, right? So it is related to data privacy and security concerns, like whatever data we are keeping in the cloud, it is related to the private informations, personal informations, right? So it should not be revealed to any person apart from the intended person, right? So if you store some confidential data in the cloud, and that information is available to some other person, like we can talk about the question papers, right? Whatever question papers we are setting, if we keep in that Google Drive, right? And in fact, if somebody is uh, intentionally or unintentionally got that question paper, then the privacy is violated. Okay. Similarly, you might aware of this man in the middle attack, right? Between the source to destination, there is a third party person, right? So who is launching a particular attack? It is observing. First, it is called as interceptions. Interception case, we are looking into how they are interacting with each other. Okay, in between source to destination, how they are interacting with each other. First, we are looking into that. Once we get these informations, then we take the advantages of like I told you about fabrications, right? Or we told about modifications, right? So this third party person, this hacker, what it is going to do, it is sending some message to the sender as well as to the receiver or destination, uh, so that they will feel that this message is originally generated from the D, or this message case it is originally generated from S. So such type of attack can happen. So that is called as the man in the middle attack. So if you are aware of the Diffie-Hellman algorithm, the popular algorithm case, where there we have this attack is applicable in that situation. There is another question here that that is challenge is related to unpredictable performance and bottleneck, right? Like I told you about Amdahl's law, I told you about the Gustafson's law, in which I mentioned that beyond a particular capacity, if you exceed a particular capacity, then uh, uh, if you exceed that particular capacity, then it is not the performance is not going to improve. Like today you are using two systems, tomorrow you increase it to 10 systems, day after tomorrow you may increase to 100 systems. But you have to look into the performance bottleneck, right? After a certain number of processes, your performance is not improving. Like we have multiple virtual machines taking the resources of the physical machines, and these virtual machines actually share the CPUs, clock cycles, memory. But there is a question on the input output. They cannot share the input and output, right? Same input output, they cannot be provided to multiple virtual machines. Their input output is different. So here the performance is having a bottleneck. Everything cannot be parallelized, right? There are some sequential part we have. There is some part which can be parallelized, but all the parts cannot be parallelized, right? That is also one of the issues. Similarly, we have another challenge, that is distributed storage and widespread software bugs. So bugs, errors, and mistake can happen in the system, right? At any point of time, there may be a software bug. Sometimes you may face some difficulty while you are writing the codes also. So software bug is in fact an error or a flaw, or you can say there is a fault in the design or development and operation of a particular computer software. These all our applications are our softwares, right? So software bugs can happen due to due to some design issues, due to some development issues, and uh, due to which you may get an incorrect result, or you are getting unexpected result. Like you are writing 2 plus 3, you are getting 10. Okay. Or you are getting -1, or you are getting 6, or you are getting 0, right? So this process we need to identify and solve it. For this, debugging is very much important. And if you are keeping the data in multiple places, you have to ensure the data should be consistent. Like if you look into our organizations are keeping the data for administrative purpose and non-administrative purpose, right? Like suppose for a particular student, the data is stored in administrative office, as well as the data is separately stored in the hostel office, right? So while a student has joined the institute, his address is maintained in the administrative office. And the student also filled a hostel form, or you can say all of residence form. So in which also he has filled one, you can say, uh, address form, right? Address of his home address and present address. A later point of time, assume that the student address is changed, and the student informed the hostel warden that my address is changed, so it is updated in the hostel database. But if hostel authority will not inform the same to the administrative authority, then the old address is there with the administrative authority and new address is there with the hostel authority. So if the administrative authority wants to send any kind of letter, right, to the student's home, then it will get the old address, which is a wrong address. So this is a clear example of data inconsistencies. Right? If you are keeping the data in multiple places, you have to ensure that the proper data is stored in both places. There should be a synchronization of this data. Like I usually face the problem with Google Drive, right? I have installed my Google Drive in my home computer. I have installed the same in my mobile. I installed the same thing in my institute desktop. I installed the same thing in my laptop as well. So sometimes I can see due to internet issues or due to synchronization issues. So what happens? Sometimes I have edited some file in my student desktop, but while I'm opening the same in the night time in home, so the same copy is not available in home computer system. There is a slight delay, or due to this is maybe problem with respect to synchronization, or this is with respect to the internet issues also, right? So such type of issues happen because we are keeping the data in different, you can say, locations, right? So we have to ensure that there is, you can say, same data need to be available everywhere so that there should not be any inconsistency issues. There is another issue that you can see that is related to scalability, or you can say interoperability or standardization. Lack of standardization we have, so that we have issues. Scalability is also issues. Like if you go for pay as you go model, based upon your usage, you are going to pay, right? Whether you take storage or you compute or any type of services you are opting in Amazon S3, okay, based upon that you have to pay. Bandwidth says that how many bytes you have used. Based upon that you actually pay. So there are many cloud service provider offers such type of scalability issues. Based upon your usage, you have to pay. If you have not used, then you have to pay the base price. You need not worry about uh, a day-to-day price, right? Because you have not used the services. Similarly, interoperability and standardization is also important, right? Irrespective of the operating system, it should work, right? Interoperability actually focus on uh, interoperability actually focus on this particular thing, right? The ability of our computer system or software to exchange, make use of information. So if it is working with X system, it should work with Y system, right? Similarly, you can make standardization if you use the open virtualization format, that is called OVA. So this open virtualization format is open and secure, portable, efficient, and extensible format for packaging and distribution of devices. Like whenever you are installing a particular VM or you are deploying a particular virtual machine, it is giving you an option to choose a particular template. Yesterday also I told you while we were discussing eyes and Zeek, I told you there is a template. Based upon that template, if you like whether you want to go for Fedora or you want to go for SUSE Linux or you go for Windows system. So you have to see these templates and look at which template is closely fit with your requirement. So These are well-defined format. This open virtualization format is a standardized format. So if you follow this open virtualization format, right, it is easy to migrate from one physical machine to another physical machine. Easily you can distribute. Sometimes these preloaded virtual machines with packages are given in various workshops and conferences so that people can directly use it without installing any plugins, right? That is also one of the challenge. There is another challenge related to software licensing and reputation study. Like if a software is offered by a cloud service provider, let's say X software is of very high cost. Let's say it is costing 10 lakh rupees, right? So we cannot afford 10 lakh rupees to purchase this particular software, right? So if the software is given by the cloud service provider and it can say you can pay, let's say, 1 rupee, uh, 1 rupee per day, or per you can say per hour. So we can use that software in cloud, and based upon our usage, you can pay to your cloud service provider. So in that case, you need not worry if a new version of X is launched in the market. Let's say this is your version 1.0, and later point of time version 2.0 is launched into the market, then your cloud service provider is actually responsible to upgrade the software from version 1.0 to 2.0. Okay, so that is our software licensing and reputation sharing, right? But what happen if there is any threat or attack in our cloud network? It leads to violation of our confidentiality, integrity, as well as our availability. It is also causes losses of billion of dollars. Like in past, many people have launched attack. Like Trojan horse is one of the example, which spread over all over the most of the part of the world. So it is having some issue, right? If it's spread a particular virus, or you can say worms or anything, spread over various continents, then obviously if the service is not available, like if the bank network is down for a period of time, then we lose $1 million. So we call this is an epidemic, right? Epidemic means it is covering most of the part, but not the entire part, right? But it leads to pandemic also. Pandemic means it is covering most of the countries, almost all the countries. So we call it pandemic. You can say epidemic, it is smaller in comparison to the pandemic. So yes, loss of confidentiality is happen if information is leaked. Information is leaked, somebody can look into your passwords, somebody can see where you kept your information through which it can access the things. So if information is leaked, it leads to loss of confidentiality. Similarly, loss of integrity happens if there is any alteration, right? If something is changed, right? Or you can say Trojan horse is launched. It is a very popular attack. Or spoofing. Okay, spoofing happens, then also it leads to our integrity issue. So spoofing means you can say whenever you are typing your password, somebody is looking into your password. So it is a type of you can say behavior that is nothing but trusting the your device to get you to do something beneficial to the hacker. Hacker can get some information and can launch some kind of attacks also. Right. So if spoofing happens, then also it leads to integrity issue. Like I told you about denial of service, right? Denial of service also leads to loss of integrity. So it loss of system operations and internet connections. Similarly, we can also have a lack of authentication and authorization. Somebody is getting your password, or somebody has authorized to do a particular work and is misusing it. Like suppose X person is called for a particular meeting, right? But X person is unable to attend the meeting. So X delegates the power to another person, let's say Y, to attend this particular meeting. So this is called as the process of authorization. You are authorizing someone, when you go for like many people are staying outside abroad and they want to sell their property in India. So they are authorizing another person or their father and mother, uh, authorizing them to sell that particular property. So they are authorizing. So sometimes authorizing also can lead to misuse because as you are giving power, whatever they are doing, that is legal. So here attacker illegitimate to use the computing resources. These all are associated with the data and resources because we are talking about the cloud, right? So we have to see that three security requirement, confidentiality, integrity, availability should be maintained in the system, right? Now, if you violate this one, you can see there are number of attacks are possible if there is a loss of confidentiality or integrity, availability, or interrupt authentication. Like if there is information leakage, okay, which causes loss of confidentiality. Why the information is leaked? Because people are doing eavesdropping, right? Like ATM counters is one of the example, popular example, where you can see while you are typing your PIN, okay, somebody is also available inside your ATM counter and he is looking into your PIN. So that is an example of eavesdropping. Similarly, traffic analysis. There is a tool, popular tool, if you install in your system that is called as WireShark. So where you can analyze the traffic. So if you analyze the traffic, then based upon that, you can see what kind of messages are they communicating and who is the sender, who is the receiver, from where you can get some informations. Then there is also another one that is called as EMRF interceptions, indiscretions of persons or media scavenging. So these all are associated with information leakage. Similarly, penetration, masquerade, bypassing control, no authorization, physical intrusion, these are also leads to information leakage. Denial of service, Trojan horse, trapdoor, service scripting also leads to information leakage. Similarly, if you talk about integrity violation, intercept if you are changing something, if you are modifying something, or related to reputation. Reputation means you are denying some information, right? Like sender is denying, I have not sent this message. Receiver is denying that I have not received this message. This also questions on the integrity. Okay. Similarly, resource exhaustion, right? Suppose you have your system can accommodate 100 of users, but after accommodating 2 users, all the resources are exhausted, right? In that case, you can say somebody has attacked your resources and make the resources busy and the resource is exhausted, so other users cannot use the resources, right? Similarly, integrity violation, theft, replay, lot many attacks are there, right? I'm not going to details of these attacks, but such attacks are there. Some of these attacks I will tell you in detail. Let us start with the issues related to BM confidentiality. Sorry, confidentiality. That is the first security requirement. And basically, we'll look into the confidentiality in perspective of virtual machines. So you know that a same physical machine is giving resources to multiple virtual machines, right? Like these are the virtual machines. VM1, you can say VM2, VM3 are taking the resources of the physical machine, right? So this is called as VM co-residency because they are using the resources of the same physical machine. We call this a co-resident, like two friends sharing a common room. So we can say they are co-residents. So what happened? In between them, they may launch some kind of attack, right? That is called as cross virtual machine attack. So one owner of the virtual machine aware that other virtual machines are also taking the resources from the same physical machines, and one of them is intruder, then they can launch one type of attack that is called as cross virtual machine attack. So co-residence, here you can see co-residence means multiple independent customers say the same physical infrastructure. Like here you can see there are three different customers. They are using the same resources. Similarly, DM co-residence has raised certain security issues that is related to cross virtual machine attack. So they are launching some attack because they know that they are near to each other, or they are using the same physical machine or same resources, so they can launch an attack. So there are some other attacks are also possible, like placement preventions, co-residency detection. Okay, until unless they know that they are co-resident, they cannot launch the attack, right? And no hype. Okay, these are some of the problems, solutions in which you can solve the problem. There is also another one is called as malicious system admin. Okay, so if the provider is malicious or an intruder is a provider, okay, intruder has lost is owning some resources and is provided as a cloud service provider, then also this type of problem can happen. So which questions on the cloud computing platforms? That's why many, if you see many government organizations, you can look into the government organization or you can look into military organizations. They are not willing to use the public cloud service provider like Amazon or Google and other service provider, right? Because they know that if once they store the data in Amazon and single server, then it may cause the problem related to the national security. That's why they are reluctant to use these cloud service provider to store the data. Similarly, come to the second one, that is integrity. So integrity lead to loss of physical control. So what do you mean by loss of physical control? You know, the data and programs are outsourced to the cloud server. Like our email system is an example. Our data and program is stored in the Google server. But it is owned by our organization. But originally these data are not kept in the boundary of our organization or our institute, right? And data program may be altered or lost or even deleted. Although there is a agreement between the our provider, but still it may happen that the data can be altered or data can be modified. And in fact, we have seen also some portion of the data of let's say Yahoo email, or you can say other emails are not available for a particular duration of time due to the data is deleted, or you can say due to that proper replication is not there, the data is not found in date. So it is difficult and impractical to ensure data and computation integrity with the traditional methods. So we need to improve our methods, okay, so that we can ensure we can provide more trust to our customer that there is no difficulty you are going to face if you are using the this particular cloud service or services or cloud service providers services. So the data loss manipulation can be avoided if there is a third party auditor. So the data need to be audited by a authorized third party. So they can analyze and give reports to both cloud service provider and the intended stakeholder of that organizations that the data is not manipulated or not lost. There is something called as dishonest computation. Dishonest computation means like if you are intended to use two virtual CPUs, right? But unfortunately, you have done applied some kind of attack, and you are using, let's say, 30 virtual CPUs, right? That may cause now the problem. As an attacker, you are consuming 20 virtual CPUs. That is called as dishonest computation. It also related to replications, computation, and trusted computing. Now, there is another thing here you can see that is called as availability. Availability means you know that service need to be available for you 24/7. Right? But there are some attacks like flooding attacks. DOS is also a flooding attack. DDoS is also one type of flooding attacks. So they consume the entire bandwidth, right? So suppose some bandwidth is allotted to a particular application and the entire bandwidth is captured through the flooding attacks. One person is launching the attack in multiple systems, right? So like I am writing a simple for loop. right? In each and every iteration, it is going to open a Google page, right? So if my for loop iterate for 1,000 times, then 1,000 different web pages are you can say yeah, 1,000 different Google page request is generated, right? But it is generated from one particular person, right? So it may leads to bandwidth under provisioning, right? Similarly, there is a attack related to cloud pricing scheme. You know, the pricing scheme of each and every cloud service provider is different, right? Each and every cloud service provider having different pricing schemes. Okay, if the pricing scheme of a one cloud service provider is known to other cloud service provider, or the internal strategy is also known to other provider, then also that is also lead to one kind of attack, like resource consumption, fraudulent resource consumption, FRC attack. So we need to detect such attack so that we can avoid it. Yes, this is related to cloud pricing model. Cloud customer are financially responsible for the services they use. Like if I ask you to use the cloud services, if you don't have knowledge that how to use the cloud services, then sometimes you may get high charge. In the last month, I have used a Amazon EC2 instances, EC2 instances in uh, one particular region, right? And I forgot to terminate that particular instance. Unfortunately, this instance is running from last 1 month. So I am charged with US dollar, let's say 20, right? But my intention is not to run this particular instance. I just want to use or demonstrate this instance in some talk or some lecture. But it is continued up to 1 month, right? So Amazon has charged me the US dollar 20 at the end of the month, in the last month, right? So that's why a customer is responsible for their services. So attacker always have an incentive to harass the billing process by exploiting the pricing model. So that is related to cloud pricing model. Yeah, I told you about bandwidth provisioning. So if you launch a DOS or DDoS attack, okay, these attacks are also applicable in cloud computing system. So if a single user is launching some attack in various places, we call that as a distributed denial of service attack. So it may cause a problem. So according to Cisco design guide, a data center is usually designed to be under provisioned with a factor of 2.5 colon 1 to 8 colon 1, right? Meaning that the actual network capacity is much less than capacity is much less than the aggregated capacity of the host located in the same subnet. That's why the factor is 2.5 is to 1 or 8 is to 1. Like I told you in the previous class about under provisioning over Jamaican, that related to the supply and demand, right? Suppose our demand is more than the supply. Demand is more, right? Than the supply, or you can the supply is less than the demand. Then it may cause so supply is less, so it is caused to under provision. But supply is more than the demand, then it may cause under provision. That's why you need to calculate the actual network capacity. You need to calculate the aggregate capacity of all the hosts that is launched in the same host, so that you can compare them. And if it is much less than, okay, if you look into that, you can find that they are much less than their capacity. Okay, so that may cause your bandwidth under provisioning. There is another issue like cloud that is called as copyright protections. Okay, copyright is intended to a particular person, but that person has intentionally shared the copyright with others. Like somebody has purchased Windows, let's say 11, right? And we are taking the same copy to install in our system. So that is also leads to copyright protections. One of such cases is called as collusive piracy. What it says, the paid client who actually paid for Windows 11, we call them colluders. Okay, so they illegally actually share the copyright content with the unpaid clients. Okay, so you hold the copyright. Like many people nowadays use Grammarly for writing the research article. Many people use Turnitin to check the plagiarism. So they hold the copyright. or their organization hold the copyright, but they illegally share, let's say, they illegally share with their friends, so that their friends there you can use their login to use the service. Or if in the software case they are getting the copy of that particular service and can use the services. So if you illegally share the copyright content with unpaid clients, or we call them a pirates. So that is called as collusive piracy. So we can easily detect it. Like nowadays, many software they are asking us that once you install a particular software, you verify with your Astute email ID. If it is, if you can verify with Astute email ID, they can know that yes, it is a genuine user. But if it is, you are given the software, but the login is not provided by a genuine user, then the pirates cannot use it, right? So in order to detect the pirates, and you can use identity-based signature and timestamped token. Like all of us are using Netflix account, right? Netflix account is also having a limited number of logins, right? You can use in your smart TV, you can watch from your smartphone, right? But if you share the Netflix username password with other person, so they are able to identify that how many users are using actually the account. So that is by the help of identity-based signature or timestamp tokens, they are able to identify. So if you go for the system defense technologies, so there are three generations we have in system defense technology, or you can say network defense technology. In the beginning phase, in the first generation, our objective is to prevent and avoid intrusions. So we want to build a system which will avoid the intrusions, or avoid preventing the intrusions. Like I'll tell you, don't click on suspicious emails, right? Or you don't install any software from unauthorized websites. Okay, so they use the tokens, or you can say cryptographic systems to safeguard the system. But in the second generation, we detect the intrusion in a timely manner. Like if a intruder is launching attack, or attacker is launching any kind of attack, within a particular period of time, you have to identify it and you can avoid it, or you can discard it, right? Like we have firewall system, we have intrusion detection system, we have public key infrastructure through which we can able to detect the intrusion in with a particular time frame. But now we are going through the third generation. Our objective is not only to prevent, avoid intrusion or detect the intrusion, but also our objective is to give intelligent response to the intrusion. If an intruder is found in from a particular a particular you can say location, we have to apply some kind of, we have to give a proper reply so that the intruder will fear to apply some kind of attack. Just like you are somebody is attacking to your system, you are giving a response to that particular attack, right? That is the current generation of the intrusion. So if you talk about our services, we know that our we have three different primary services. One is infrastructure as a service, platform as a service, and software as a service. So if you go for these three different type of services, this three security requirement: confidentiality, integrity, and availability, is not entirely given to the user or not entirely given to the provider, right? Like as a IAS user, you are responsible for confidentiality. But as a IAS provider, let's say Amazon is the our IAS provider, so they have to ensure the integrity. Okay, so we have divided our responsibility, security requirements among the user and provider. But if you go for platform as a service or software as a service, so in this case, both user and provider is responsible for integrity and confidentiality of any message or any resource usage, right? But if you compare cloud security with the traditional IT security mechanism, you will find these are some of the differences. Like cloud security case, we have third-party data centers like Google and Amazon. They are maintaining the data center. But the traditional IT security, you have your in-house data centers, right? So obviously, third-party data centers are more prone to attack, but in-house data centers are less prone to attack, right? Because you are not maintaining the infrastructure, right? That's why, yeah, you may face some issues related to the cloud security. And if you look into the cost, if you want to maintain the security in your traditional infrastructure, it is resulting high upfront cost, right? Like you need antivirus, you need firewall, you need intrusion detection systems. Anything you have to pay your own because you are maintaining your own infrastructure. So it is high upfront cost. But if cloud is managing, your provider is managing, then obviously it is low upfront infrastructure investment. But scaling wise, traditional IT security is very slow. But if there is a new mechanism is developed, your provider has incorporated it, you can get it, right? But if you are you want to incorporate that new mechanism in your infrastructure, so it is a cost. You need, it is expensive process, right? So scaling wise, it is slow scaling, but cloud is the case. It is quickly scalable. If you look into resource utilization perspective, utilization is very low in the traditional IT security mechanism, but here resource utilization is more. And longer time to market in the traditional IT security, here reduced time to market because many people are using that particular service. So overall, you can say the cost of traditional IT security is more in comparison to the cloud security mechanism. Okay, now these are all related to the security, but I have not discussed anything related to privacy or trust or reputation. So let us talk about privacy also. Like if you want to safeguard your data, then it is a security issue, right? If you want to say that my data need to be stored in a very safe place, that is a security issue. But when you say that identity of a particular person should not be revealed, then that is a privacy issue. Okay, your private information should not be available to other. So always there is a trade-off when you go for the security and privacy mechanism. You will find there is a trade-off between efficiency of a cloud service and security and privacy. Like I usually give an example. For example, you want to travel from Warangal to, let's say, you want to travel to Hyderabad. Okay, the distance between Warangal to Hyderabad is 140 kilometers. And in between, we have two toll gates, right? This is one, there is a toll gate close to Hyderabad. There is a toll gate close to Warangal, right? So I'll tell you, let's say 140 kilometer you have to cover in 90 minutes, right? And let's say there is a long queue in the toll gate, which takes, let's say, 10 minutes each. Assume that there is in each and every toll gate, in order to pass the toll gate and pay the fee, you have to pay some amount, and it took 10 minutes. So 20 minutes already gone out of 90 minutes, right? So you have to cover 140 kilometer in, you can say, in 70 minutes, which is practically not possible, right? So we are looking into efficiency of the cloud service. Efficiency of the cloud service means you want to cover 140 kilometer in 70 minutes. That is efficiency of the cloud service. But you are not able to do it. Why? Because there are some security and privacy policies we have. We have check gates. We have toll gates. Because of that, we cannot pass or cannot reach to our destination within our stipulated time. So always there is a trade-off with respect to efficiency and security and privacy. Now here you can see already we have discussed this thing, like these are the service models, these are deployment models, and these are some of the basic components like virtualization, and virtual machine manager or hypervisor, storage, cloud network, and multi-tenancy. But if there is some issues, okay, related to this one, there may be an issue related to software privacy security. It may be issues related to information security, storage privacy security, and network privacy security. Privacy can happen at any point, right? Privacy issues may happen with respect to software. Like I told you, pirates are there. Infrastructure wise also, if your data is kept in the infrastructure may also cause some privacy issues, right? And storage case also you have privacy security, right? Network case also you may have privacy security. So in order to avoid that, there are a lot of mechanisms we have in order to protect the security as well as privacy. We have a lot of algorithms in the literature. Like one of the other security requirement, you can say, apart from this confidentiality, integrity, and availability, is that access control. Access control says that the permission is given to the legal user to use the resources or the data. Permission is only given to the authorized people, not to the unauthorized people. Access control ensures this one. So in order to deal this one, many people come up with different algorithms. Like one of the popular algorithm nowadays people are using, that is called as ciphertext. Okay, like plain text and ciphertext, right? The original text is called as our plain text, and once you have encrypted the original text, we call that as a ciphertext, right? So here there is a policy that is called as ciphertext policy attribute based encryption. Nowadays people are focusing on attribute based encryption. Okay, like our data is having different type of attributes, right? Like if you talk about distributed system, a user is able to access the data if a user possesses certain set of credentials or attributes. Username is an attribute. His date of birth is one of the attribute. Which location is retrieving that thing? It is also considered an attribute. So if you go the previous methods, the methods are enforcing such policies to employ a trusted server to store the data and to provide the access control to that particular server. However, if any server is storing the data, it can be compromised. Like security, we have seen security issues is there in each and every case. Not only it is there for the cloud, so confidentiality of data can be compromised. In order to avoid that, people are coming with attribute-based encryption. If you have some attribute, like I am considering one attribute is date of birth, through which I will make some kind of encryption. I am not doing the encryption through all the things, and that is known to only the intended user, through which they can extract the data. Similarly, attribute-based encryption can also done based upon the key. That is called as key policy-based attribute encryptions. Okay, that is another method. Similarly, fine granularity method is there. You can say coarse granularity methods is there. Multiple authority methods are also there, right? Like that, there are a lot of methods we have in the security and privacy-based algorithm. Similarly, revocations mechanisms we have. You can retrieve the data through a particular attribute and user. Like for example, a user one having attribute date of birth. User two is having having address. Okay, user three is having the data related to, let's say, the bucket name, something like that. So you can retrieve the informations by you can retrieve your data by using attribute as well as user. And the tracing mechanism can be white box and black box. Black box, internal details is not known to you. White box, it is very transparent. Many people also applied proxy re-encryption, hierarchical encryption, searchable encryption, multi-tenant, that is same application, and that is used in the separate use a separate database. You can go for trust and combination of various other technologies. Yes, this will give you the attribute-based encryptions. Like this is the user, and this is the owner of the, or you can say cloud service provider, who is holding some servers, right? So in between the user and provider, we have a trusted authority, right? Like there are our registry is there, right? Suppose you want to purchase a land or you want to sell a land, we have a trusted authority where owners is trusting that one, user is also trusting that one, right? Like some policy you want to enforce, right? So your user need to believe that one, owner need to believe this one. So we believe in a third party, which is called as trusted authority. So trusted authority provides a public key to the owner, right? Like our email is considered, email username is considered as the public key, and trusted authority is providing a secret key to the user. How a user can access to the data through the secret key, like our email system, our password is considered as a secret key, and public key is provided to the owner. So if a user wants some services, so the user has to request to the public key to that particular owner, but can get the information through its secret key. But both of them are getting the data. Like if a user has given some data to the owner has to store the data in an encrypted form, not in the form of plain text. So it is stored in the cloud server in ciphertext form, and user can claim to the data or revoke that particular data through uh, a particular attribute, right? So that the ciphertext can be again be converted, or user can use the secret key to convert that ciphertext into the plain text. Yes, this is the step-by-step process. You can see user has made a search request, right? And once it make a search request, the cloud server has arranged that particular reject, right? So yeah, in between the owner and user can also communicate with each other related to the access control or source control. And owner is store the data in the form of an index structure, because retrieving the data is easier if that is an indexing structure. If it is properly stored, then only it is easy to uh, extract the informations. Like you know about different type of mechanism, like open hashing and chaining, and there are different methods you have studied in data structure, right? Quadratic probing, linear probing. These are different indexing mechanisms that you can use to solve the problem. So this is all about the security and privacy mechanism. Let us focus sometime in the trust and reputation. So trust is in between the service provider and the cloud user. Like if you ask me, then I can tell you a story. Like in 2010, around 2010 and 11, when these e-commerce sites are launched, like Flipkart, Amazon, and I am very much interested. I was interested at that time to purchase a book from this site, but I don't have trust on this e-commerce site. At that time, there are so many frauds happen. So what I felt that okay, let us purchase the book from this provider, because the cost is very nominal. If it is coming fine, otherwise we'll see some. We'll ask for refund, or we'll go for the legal process, right? So the book which I ordered at that time, it was delivered very nicely by the different by the e-commerce site like Flipkart. So I built my trust on that particular e-commerce site. But if you see after a 10 years time or 10-year period of time or a decade, nowadays if anything you want to purchase, you are going to e-commerce site rather than visiting a nearby market. You can say the cost is, you can compare the cost, you can see the feedback, you can see the rating. Based upon that, you can take a decision. So trust is purely between the service provider and cloud user. Like one user can say this particular provider, CSP, okay, is providing the services in a very nice way. Whereas if you ask the another user, he has different opinion about a particular provider. So trust is a social problem. It is not a pure technical issue. If the user is saying no to this cloud service provider, is this user is saying yes to the cloud service provider, there is no conclusion, because there is no technical issue, not a pure technical issue. It is purely based upon our society. But you can solve this social problem, okay, through technical approach. Like if a user is not satisfied this one, then the CSP need to address that particular query. If there is some problem, CSP can provide some kind of discount, or CSP can provide the solution to that particular problem, so that we can build trust on that particular cloud service provider. So we need also a healthy cloud ecosystem. Healthy cloud ecosystem says that it should be free from various abuses or violences, cheating, hacking, virus, rumors, pornography, spam, privacy, and copyright violation. These all need to be avoided, right? So if it is free, then definitely the trust is going to be built on a particular cloud service provider. So there are three basic security enforcement we have. One is called as a security in the data center. In order to secure a data center, we have biometrics reader. Okay, like we have fingerprint, we have face recognition, we have iris recognition. Okay, so through which you can say that the person who is entering to the data center is a genuine person, right? You can also put a CCTV to monitor a particular data center. Suppose you want to know who is inside the data center, where he is, what he is doing. That can be monitored to the CCTV. And due to the emerging of IoT devices, you can also go for motion detection, right? Like if you go for coal mines area, nowadays we deployed the motion detector sensor. If there is any person stuck at any particular place, so we can easily detect, and if any main trap is also there, we can identify and you can take preventions. We have also network security issues like firewalls, IDS, third-party vulnerability assessment, through which we can ensure that there is our network is completely secure. We have platform security mechanism, like we have SSL, that is secure socket layer. We have SSL certificates also. It is a very popular protocol which ensures that you can establish a secure links between two different components or two different computers. Right? It also uses, you can say, TLS, that is transport layers security mechanism, to ensure that TLS is, you can say, it is an improved version of SSL, so you can ensure that it is more secure. Similarly, strict password policy you have to enforce. Like nowadays, if you want to set a particular password, then people say that yes, it should be the passwords should be having special characters, lowercase letter, uppercase letter, numbers, so that we can avoid it. This is, you can see, with respect to IAS, PAS, and SAS, and with respect to the cloud service model, you can say, with respect to the type of infrastructure you are using, including applications API, what are the corresponding attacks can possible. Like if you talk about data and information, the data less protection, common log files, a database activity, these are the things that you need to concentrate when you are looking for defense mechanism for cloud security. Like here you can see these are the issues related to networking, trusted computing, and compute and storage. Like we discussed about anti-DDoS attack. If you launch anti-DDoS attack, we can protect our network. If you go for intrusion detection system, firewalls, okay, you can safeguard the network. Similarly, if you manage the log, if you apply the masking mechanism, if you apply the coloring mechanism, then you can also save the computation and the storage type of applications. Yes, there is another attack that is called as malware-based attack. That is because of the network worms, virus, and DDoS attack. So you can also look into this attack and provide some solutions so that such type of attacks can be avoided. Like we can provide intruders unauthorized access to the critical information. If there is any critical information, we have to ensure that, or you can go for two-layer security. Instead of a one layer, you can go for a two-layer security, so that even if we break one layer, another layer is there to protect from the attack. Right. So cloud components that demand special security protections. These are the specific components which require more secure, right? Like you can say, If this data is compromised, then it is okay, but the next level data should not be compromised like that. So protection of servers from malicious software attacks such as worms, virus, and malware. If you are using a outdated versions, this may cause to this type of problem, that is malware-based attack. Protection of hypervisor or VM monitors from software-based attack or vulnerabilities. Or protection of virtual machines monitors from service disruptions and DOS attack. Right? So these are very sensitive when we are looking into the security policies. Some more are, you can say, protection of data and information from theft, corruption, and natural disaster. Sometimes nobody is going to attack your system, but there is a natural disaster happen, which leads to the data loss. So you have to provide a recovery mechanism and providing authenticated and authorized access to the critical data and services. In this context also, you can see some of the security challenges in virtual machine, like hypervisor malware. Hypervisor is our virtual machine monitor. If there is any kind of worm, network worm injected into, let's say, into our hypervisor, that also leads to attack. Similarly, guest hopping and hijacking or VM rootkit attacks are also one of the issue. When in the middle attack, we already seen there may be number of attacks like active attack, passive attack, which also create challenges to our cloud system. If you go for IDS also can be looked into two perspective. It may be a network-based IDS or it may be a host-based IDS. We can focus into that. So if you go for cloud defense mechanism, virtualization actually enhances the security because in comparison to the physical machine, virtualization provides a better security mechanism, right? Because virtualization is an abstract environment. So physical environment attack is more, but if you go for virtualized environment, the attack is less, right? So because physical machines, you know that who is the intended user directly, but virtualization you have to apply multiple users are using the same system. Getting the detail of the informations is very difficult. So in this table, you can find some of the protection schemes like secure data center and computer building, use of redundant utilities at multiple sites, trust delegation negotiation, worm containment and DDoS schemes, reputation system, fine-grained file control, copyright protection, piracy prevention, and privacy protection. And their description is there. I'm not going in much detail about this one. Like here, you can see there are some defense mechanism with the virtualization. Like the data is stored in the digital form. Digital means it is binary form, right? So getting the information is in fact difficult, right? Binary data is reading. If I give a binary file of a particular program, it is difficult to identify this one. And VMs can be saved and it may be copied or cloned. It may be encrypted, moved and distorted whenever you are migrating from one physical machine to another physical machine. So that if anything happened to that particular virtual machine, we can launch a faster discovery and disaster recovery mechanism to retrieve that particular virtual machines. Similarly, live migrations also sometimes also cause man in the middle attack. Okay, if you are migrating from one physical machine to another physical machine, the intruder who is in the middle can launch an attack to get the details of that particular virtual machine. So if you look into different provider like Yahoo's Pipe, if you see, they have lightweight cloud platform. Like initially only I told you, if you want to enforce any kind of security policies, first you need to go for a lightweight mechanism. Otherwise, if it is a heavyweight platform which consumes more energy, it is going to impact our execution efficiency. So in order to avoid that, you need to go for a lightweight cloud platform. Similarly, Google has its own in-house software to protect the resources. Amazon uses HMEC, and Amazon also uses the very popular one that is X.50 certificate to avoid the problem, right? So these are the different mechanisms that is used by this one. Like if you if you look into different cloud service provider, they have different type of policies. But make sure that that policy is a lightweight policy, right, to avoid the problems. These are some of the desired security features in the secure cloud. So I'm not going details because you can read this thing is very clear, like single sign up, single sign up. Like in the Google account also, if you go to your manage account, you can get a single sign up option. You can sign up from all the device. If you click the option, then all the devices where you have logged into your Gmail, that can be out, right? Similarly, dynamic web service with the full support from the secure web technologies, establishing trust between the user and provider through service level agreement. If you provide a detailed highlights on the security in SLA, then definitely your user will interested to opt your services by looking into these terms and conditions. And effective user identity management, data access management policy is also required. Auditing is required, periodic auditing and copyright compliances will increase the visibility of a particular cloud service provider. And shifting the control and data operation from client environment to the cloud provider, that will also solve your problem. And protect the sun from sensitive and regulated information in the same environment. Like one virtual machine is used to resources of the same physical machine where other virtual machines are also using. Right, multiple VMs are using the same physical machines. So that is a shared environment. So how to protect it? That is also one of the security issues. Like if you see here, the XML gateway, it is connected to different services. Like it is connected to application server, message queue, and database through different framework. Like here I am using HTTP. Here SQL is used. Here JMS used, Java services. Here XML is used. Here SSL is used. Right. So it is just like a centralized control. So if we can if an attacker can launch some kind of attack with this XML gateway, then it is easy to retrieve the information from the different servers, database, and you can say different queues, right? So that type of things you have to avoid it, right? Through secure circuit layer, or you can say through transport layer security. So just I want to show you another one, an important part. Like here you can see a scenario of a DDoS attack. Like here you can see this is the victim. This computer is the victim, and these computers are launching DOS attack. Okay, and they are not launched from a single place. They are launched from different places. Like here you can see this computer who is launching the attack. That is, you can say DDoS attacking zombie. It is connecting to the router 7. Okay, so it is launching the attack from R7, and this attacking zombie is launching from R6, and here it is from R5. Here it is from R3. So different routers we have through which we are launching attack, right? But our intention is to reach to this particular victim. So we follow different path. Like R3 is connected to R2, right? R2 is connected to R1, and R1 is connected to R0. This is one path for the attacking zombie. This one. And if you look into R5, R5 is connected to R4, R4 is connected to again R2. Follow the same path to reach to the victim. Similarly, R6 is connected to R8. Okay, R8 is connected to R1 and R0, and the last one R7 is connected to R9. R9 is connected to R0. So finally, all the flows you can see they are meeting at one point, that is R0, to attack the victim. Right. So you can see these attacks are launched by a single attacker, but from multiple places. Right. So they can attack the system and they can flood the packets or launch some kind of attack so that the services provided by this particular victim is not going to reach the customers. Right. So flooding traffic is large enough to crash the victim server. Like it can suppose it can launch, it can provide services to 5 customers. So already 4 requests came from the same attacker, right? So it can provide services to only one customer. Like that, they increase then the flow, right? So it is going to crash the victim server. Either the flow buffer of this victim is overflow, or resource is exhausted, or disk is exhausted, or connection saturation happens, so that the service is not going to be available. Yeah, here you can see there is a attack between two different virtual machine monitor. Like here we have a virtual machine monitor. Here we have another virtual machine monitor. Right? That is hypervisor. Okay, so there is a VM instance here. We want that VM instance to migrate to another VM instance. But while you are migrating this VM instance, it is suffered from the main in the middle attack. Okay, so an attacker can modify some of the application state, or it can modify the arbitrarily virtual machine operating system. So migration, while you are migrating through a unsecure network, so main in the middle attack is very easy to the system. Main in the middle attack is very easy by the attacker, so that it will modify something in the VM, which leads interruptions, right? It can interrupt also, it can send to a malicious virtual machine monitor. Let's say this virtual machine monitor is not a original person. Then we can also migrate and it can cause some kind of issues. Okay, then I'll tell you about something related to the reputations quickly. Yeah, many people also applied the data coloring and data watermarking policies to avoid from the interruption. Like many whenever we are preparing a particular certificate, or if you look into your degrees or certificates, you can see there is a logo, okay, in the background, right? It is not clearly shown, but you can see there is a logo. So that is also one example of an watermarking. In Microsoft Word also we have a watermarking policies, right? And different data coloring mechanisms are also there. So you can color the object, like I can color a particular object with green color, another object with red color. So whenever I am storing the data, I am coloring it, and whenever I want to retrieve the data, I need that same color to retrieve that thing. So each and every data is assigned with a unique color. So system is generating the unique color for each and every data object. So here you can see the service provider and data owner is there. Data owner is kept storing the data in the virtual storage in a particular color. The object is stored with a particular color. Service provider has assigned it. So whenever that owner again wants to retrieve the data, he has to again uh, locate the data through that particular color. So we can say decolor of the data object. So what we are doing here, actually we are matching the request made by the data owner and service provider. If both are actually matching, then only the data is going to be retrieved, otherwise the data is not going to provide to the data owner. Yeah, data lock-in problem, I already told you. I'm skipping this slide. Yeah, there is another part in the security that is called as reputation. Reputation is a public opinion. If I ask you, should I use Amazon EC2 or not? So it is a public opinion. It is not a personal opinion. But if I ask you whether you trust Amazon EC2 or not, then your answer should be yes or no. So that is your personal opinion. But reputation is not based upon your personal opinion, but it is based upon the society opinion, you can say, or you can say public opinion. Okay. So trust can be very subjective or biased. Somebody does not like one particular service, can say that don't use this service because it is subjective. Okay. Suppose you trust your friend, whatever suggestion he is providing, he is giving, and you are easily accepting that one. He told that don't use this service, so you will not use it. So that is a biased one. Maybe that is a biased one. But when you go for reputation, it is more objective. Reputation is about the society. If many people are talking about a single thing, then maybe it is correct, right? So biasness can also be avoided through the reputation. So in order to build the reputation, we have two type of system. One is called a centralized system. Centralized, it is very easy to implement, but prone to failure, right? So when you go for distributed system, it is more complex. Obviously, it is not causing failure, but uh, it is not placed in a single place. So monitoring and implementation is very difficult. And both centralized and distributed systems are having a user-oriented as well as the data center-oriented. Like you know about eBay, right? It is a social networking website, or any social networking website if you see. So these eBay is providing electronics, or you can say cars, fashion, and other things, right? And many people are registered with the eBay also. So in that case, you can go for reputation system, that is user-oriented reputation system, right? Which talks about an individual user or an organization or a particular agent, right? But if you go for data center based, like Google and Amazon, they are placing different data center. But eBay is a company; it is e-commerce company. We are focusing on a particular agent. But when you need data center based, you have to ensure that the cloud service provider is having multiple data center in the world, like Google and Amazon. Like many people also provide solutions. Like here you can see this solution actually manages the trust in the P2P system. This is a solution provided by two different authors. And peer trust is developed in Georgia Institute of Technology for e-commerce application. Eigen trust is another also solution. Similar data center case, there is another author, that is who they have used, and power trust is another mechanism that is used by University of Southern California. They have used it to provide the solutions, right? So overall, what do you need? You need a lightweight security framework, right, which provides easy access to the user without interrupting the execution efficiency. So we can say we need cloud security as IT security. Today, everything is stored in cloud, right? So you can say IT security is now not important. We call that as a cloud security, right? In fact, the IT security is merged with now cloud security. And if we can design a security as a service, right, mechanism where we can provide a better security mechanism or a lightweight security mechanism, or we can monitor the activity and various security policies, which helps which builds the trust among the customers, and which is affordable by the cloud service provider. Definitely, the security problem can be. So the security policies is need to be developed without any interruption to the computation. If it is impacting the computation, then definitely people will not have hesitate to use that particular services, right? Like here you can see one example I can tell you also, like if you go for service level agreement, right? There you need to focus on security policies, right? CSPs need to highlight that particular security policies, whether to use a single key or to use two keys, or whether to use a watermark system or color system. That security policies need to be defined by both the parties, right? Then only we can build a trust and provide easy services to our customer. Okay, we'll stop here. If you have any question, you can ask.